Hi, chapter 2, statistic. On this page, we are talking about what is a statistic, and refer to numerical fact, number that represent income of the family, age of the student, salaries of typical college graduate. And then a statistical group of methods that are used. What we do is normally collect, analyze, and interpret data. So when you go to the example, then you understand how this process works. Two terms that we use very often in the stat is these two, population and samples. Sample is when you take selection of a few elements from these populations. And population is when collection of all elements of interest. So this word all is a very good indication to understand that what you have is the population, it's not the sample. And here is some examples. Like age of all members of the family, all members, populations. Number of days missed by all employees of the company. See, this word all is a good indication to understand that this is populations. Cattle owned by 100 farmers in Iowa. See, you understand in Iowa, obviously there are more than 100 farmers. There might be like thousands of farmers, but we are just selecting 100 of them. So that would be an indication of the samples. Scores of all students in the stat class. So it's populations. Marital status of 50% selected. So 50 selected out of a large city. So that would be a sample. Now, here we want to talk about frequency table. Let's assume that here, let's say in one place, there are there are 5 marbles, and 3 of them be labeled as A and 2 of them as B, okay? So if I want to create a frequency table for this, the letter of A, how many A's do we have here? 1, 2, 3. So the frequency of letter A is 3. What is frequency of letter B? How many of letter B are there here? 2. So this is frequency table. And later on, we talk about relative frequency. To calculate the relative frequency, you add these two, and out of five letters, how many of them are A? Is 3 out of 5. And how many of them are letter B? 2 out of 5. And you understand the sum always has to be 1 or 100%. Okay, because look, they have 0.60 and 0.40, or 60% of 5 letters are A and 40% are letter B. Okay, so this is what the frequency table is. How many of each items do you have or present here? All right. In this example, we actually went to a college and randomly asked the students about their majors. 5 students show interest in business, 7 in economic, 8 in MIS, 14 is just a BS, and 6 others. So this is the frequency of, now, what you see on the right is a bar graph or histogram. How do I graph it? The vertical axis is a frequency. See, this is a frequency. So you put that on the vertical axis. And then on the horizontal axis, you draw a rectangle for each of these measures. Like for the business, its frequency is 5. So here you pick 5 and you make a rectangle here. Economic is 7, so you do that. So one of the advantages of the bar graph or histogram is when you want to present that, if somebody look at this graph, you understand that the highest number is for BS, the people who want to just get a bachelor's degree. Okay. So that's what the bar graph or histogram is. And here is the explanation. Histogram is a bar graph in which horizontal scale represent class of data value and the vertical scales represent the frequency. And you understand that all these bars are drawn adjacent to each other. See, there is no gap. What if all the frequency are the same? See, if the frequency remain the same, this is another example, then you see this is what you have. They call this uniform distributions. So histogram or bar graph is in uniform distribution if all the frequency are equal. Now we want to talk about some of the definition, the class width, lower class limit, upper class limit, class midpoints. And all these definitions we understand by going over the example on next page. But you need to understand that the class weight is maximum value minus minimum value over number of classes. Okay, look at these examples here. I have a frequency table. This is related to the example that we had a bar graph. In this one, we put a frequency for each major. And I think this is a biology. I said bachelor is a biology. So how do I calculate the percentage of student interest on each major? You add all the frequency, which in this case is 40, total of 40 students. It was randomly selected. And then you take each number and divide by that. This is percentage. When you see it in a decimal, if you want to convert the decimal to percentage, you understand that you move the decimal point 2 digits to the right. So 35% of 40 students have interest in biology. 20% is MIS and so on. The total is always 100%. And this is a better graph you have here. So if we ask you to graph and have your vertical axis as a percent, that's how you do it. So here, in this case, your horizontal axis is the major, and the vertical axis is a percent. They call this Pareto chart. Pareto chart is when you put the highest frequency or percentage first, and then you put the lowest one here. So it's always declining like this. So you put it in order from the highest percentage to the lowest number. This is Pareto charts. So if you just want to have a regular one, this is just a regular bar graph, based on all the majors. But if I put all these numbers in order, like this, if I put all the numbers in order from the highest to the lowest, then when you graph it, you see something like this, which is a Pareto chart. That's just a special type of bar graph. What is normal distribution? We use that very often. So let's look at this histogram. If I take the top point of each rectangle and kind of connect it, you see sort of a curve which has a bell shape. So when you graph a histogram, a normal distribution is a bell shape similar to one superimposed in the figure. This is another example of Pareto chart. Next is a pie chart. What is pie chart? Pie chart is a graph that depicts categorical data as a slice of the circle. Size of each slice is proportional to frequency count for the category. Let me just put that one here. So this is the pie chart. Okay. See, you put a percentage here. And this is how to do it. Like here, 13% of the total is for these items. So you take that 13% of 0.13 and multiply by 360 degrees, 47. So you graph that 47 degree here. So it's not easy to see it, but this is 47 for friends. It's 47%. All right. Now, when you have the distributions, the histogram shown here depicts different 4 common distribution shape. This is bell-shaped normal distribution. This is a type of bar graph or histogram that number, the frequency goes up and then drop. But it does have a bell shape and it's kind of symmetric. If I draw the line, the vertical line here, this vertical line kind of split this graph into 2 equal pieces. Uniform distribution, remember, is all the frequencies almost the same. Now, when you draw the bar graph, sometimes you see a bar graph that the frequency goes up and then suddenly drop. When you have histogram looks like this, they call it skew to the right. And this is skew to the left. So depend on type of frequency table, when you graph it, you may see one of these 4. Skew to the left, so majority of it are here. Skew to the right, and so on. Now, in this example, we want to show you how we randomly collect the data and create a probability distribution. So what we did, we actually went to one of the hospital or clinic and we collect pulse rate of 40 female patients. And these are the numbers. We took all the numbers. So you went to the 40 and you randomly selected 40 files and you keep recording all these numbers. They are not in any order, right? What we want to do is we want to construct frequency distributions or frequency table based on these items, which is basically here, okay? So now I want to go over this lower class limit, upper class limit, class boundaries. These are all, you know, these pages are all coming from your textbook. So if you want a better picture, you could go through the textbook and find the page numbers. But so what we do is first we take the lowest, what is the lowest and the highest number here? The lowest number is 60 and the highest number is 124, right? Now, class width is maximum value minus minimum value divided by number of classes, okay? So here, what is this number of classes? What we do is we take we decide, this part is up to you. How many rows do you want? I'll take a maximum value, which is 124. I'll take a minimum value, which is 60, divided by 7. Let's say I want to create my frequency table, and I decide to have 7 rows. Again, this is optional. Somebody decide to have 5 or 8 or 10. So this number is optional. You could put any number, but normally we use like not less than 5 or 6 or not greater than 9 or 10. But you know, here it was just 7. I'll pick 7. So when I take the difference of these two and divide by 7, I kind of rounded up or run down to 10. So the class weight is 10. Now, where do I use this? We said the lowest number is 60, right? So we write that, and then add 10 to this 60 is 70, 80, 90, and 100. Okay? So look, I have this class with 10, right? Then you write your first number is 60, add 10 to it is 70, 80, 90, 100, 110, 120. That's where we use the class width for the first column. So the difference of these two is the class width, which is 10. So if we give you a frequency table and they ask you to find the class width, all you need to do is subtract these two numbers, or these two numbers, to find the difference. So we take that 10 and add it to this 60, 70, 80, 90, 100, 110. All right, so how do I find the second columns? It goes from 60 to 69. The difference is just 1. 70 to 79, 80 to 89. See, you cannot put 60 to 70 because you already have 70 here, so you just put 69. Now, when you establish your first column, then you start tallying the numbers. Like, how many numbers are between 60 and 69? So you go through this table, you start counting how many numbers are between 60 and 69, and you just draw a line so you don't repeat it again. Okay, so based on that, I have 12 numbers. 12 numbers are between 60 and 69. 14 numbers between 70, 79, and so on. I didn't have any number between 110 and 119. There is no number between 110 and 119 here. So you have that one here. So this is a frequency. Now, how do I find the relative frequency? First of all, before you go further on this, you need to add all these numbers to make sure it's 40. That's how you could check your frequency table to see if it's correct or not. 40 is, there are 40 numbers here, see? Pulse rate of 40 females. So we want to make sure that the total frequency match in that case means you have counted every single numbers. How do I find the relative frequency? You take this first, each frequency divided by total. I show it to you, 12 divided by 40 or 14 divided by 40 and so on. The relative frequency also should be 100%. See, like if there is one classroom and there are, let's say, 4 females and 1, 2, 3, 4, 5, 6 males, then if I want to create a table of frequency for this one, look, I just put female. What is the frequency of female student? How many do we have? 1, 2, 3, 4. What is frequency of males? 6. There are 6 of them, right? And I want to find the percentage of each or relative frequency. Relative frequency. The total is 10. 4 divided by 10. 4 divided by 10, or 0.4, or 40% of people or students in this class are female, and 60% are male. The total always should be 100%. So when you find the relative frequency, the total percentage must be 100%, so you know your table is correct, okay? See, that's why I have this 100% here. Now, what is class midpoints? Class midpoints is these are your class. They call the first column, all these numbers, they call it lower class limit. LCL is lower class limit. UCL is upper class limit. Okay, so if you ask you what the lower class limit and upper class limit is, these are all lower class limit, and the second column is upper class limit. Now, class midpoint is a number exactly in the middle. How do I find the number exactly between 60 and 69? Take the average. 60 plus 69 divided by 2, it gives you 64.5. So that's how you take the average of two numbers. Where do I get 74.5? 70 plus 79, you add these two divided by 2. It's just like taking the average. All right, so then I show you the graph, the histogram. This histogram, it does have frequency on this side, and the class here. So when you use this for your horizontal axis, 60 to 69, you take this 60 to 69, you put it here. And what's the frequency 60 to 69? 12, right? So you just say 60 to 69, and frequency is 12. 12, 60 to 69. Then the next one is 70 to 79, 14. 70 to 79 is 14. So when you take these two and graph it, you understand that there is a gap here. Why there is a gap? Because you jump from 69 to 70, okay? So what we need to understand here is that when you do that, you create a histogram with the gap. Now, if I want to have a graph that has no gap here, let's say I want to have a graph rather than being like this. This is what I have. Let's say I have something like this and I don't want to have any gap. That means you have it like this. So for this, we need to create a new column. They call it class boundaries. The difference is the class boundary doesn't have any gap. Now, how do I find that? How do I find the class boundaries? You understand that the difference of 69 and 70 is 0.5. So you take 0.5 and add it to all the numbers here and subtract from all the numbers here. So that gives you a new column. They call it class boundaries, 59.5 and 69.5, okay? And when you want to graph it here, you could just put 59.5, or you could even start, because it's kind of small, you could start from 60 to 69.5, and then 69.5 to 79.5. That's how to get rid of the gap and have the new graph. Okay, so you understand? In the frequency table, these are lower class limit, upper class limit, frequency, relative frequency, class midpoint, class boundaries. And the whole thing is frequency tables. So, so when you read these definitions now, what is lower class limit? What is upper class limit? What is the class midpoint? What's the class width? You understand all by looking at these examples here. And we ask you to find all this. What is class width? What is lower class limit? Upper class midpoint, class boundaries, and so on. See, they all are here. You see that you understand the definition by using that example. Now, in this example, look, it said, identify the class weight. We understand that the class weight is the difference of these two. See, goes from 50 to 54, the difference is 4. Go from 54 to 58, the difference is 4. So that is your class weight. So they ask you to find the class weight. What is the class midpoints? Remember, the class midpoint is you take the average of these two. So it's 50 plus 53 divided by 2, 54 plus 57 divided by 2. What is the class boundary? What's the difference between 53 and 54? One, half of them is 0.5. It's kind of always like that. So you add 0.5 to this and subtract 0.5 to those, all right? So this is a blank table that you need to fill in, and this is the solution to it. See? I'll show you where we got all those numbers. Like you have, this is relative frequency. And this is a cumulative frequency. What is cumulative frequency? You keep adding. Look, the first frequency is 1. How many numbers are from 50 to 57? 3 plus 1 is 4. How many numbers are between 50 to 61? You add this. 5, 3 is 8, and 1 is 9. How many numbers are from 50 to 65? You add all these numbers. So when you come up with the cumulative frequency at the end, these two numbers should match. So you have 35 here and 35 there. That's for if he asks you to come up with a cumulative frequency. I show you the class boundaries. You just add 0.5 to all these numbers and subtract from it. That's how you come up with the class boundary. Class midpoint, you take the average of these two. See, explain that here. How do I find the class width? Class width is the difference of those two numbers. So you go from 54 to 50, that is 4. That's your class width, okay? Go from 50 to 54, 54 to 58, that's the class width. This is another example that we give you nicotine level of 40 smokers, and we give you the first column. All you need to do is tally. The good thing is in this one, we put all in order for you already from smallest to the highest. So you keep counting how many numbers are between 0 and 99. You tally to see how many numbers are between that. And when you do that, then they ask you to do some graph. Class boundary versus frequency. So when you have this table, then based on information that you have provided on this table, then we ask you for some graph. Like here, we want you to graph class boundary versus frequency, or here we want to ask you to graph class boundary versus relative frequency. So first you need to fill in information here. See? So you have this, you have the first column, see, lower class limit, upper class limit. You take each number and divide by the total. The sum always has to be 100%. Cumulative frequency, he explained to you what it is. Number of classes, where does 5 come from? We decided to have 5 rows, right? 1, 2, 3, 4, 5. Remember, this is optional. In the earlier example, we used 7, here they use 5. And then, like here, they ask you to find class boundary versus frequency, means they want us to take this column and put it here, and class boundaries and put those numbers here. So when you graph it, you don't see any gap. It's kind of dark. Here we ask you to graph class boundary versus relative frequency. See, when you have the table, you could come up with several graphs. Some of this graph, like here, is class midpoint versus frequency. See, in that case, is that you have just a point, because both columns, midpoint, frequency, both are just numbers. They are not. See here. And I have a better picture here. Like class boundary versus frequency, right? So this is your class boundaries, and this is your frequency. So you put all these numbers are here, and class boundaries are these numbers. See how we have it? Instead of, when you subtract, look, when I add 0.5 here, what do you have? You have 99.5, 199.5, right? But when you subtract from this number, when you subtract 0.5, see how you have 19, this should be minus, right? Minus 0.5, because you're subtracting from 5. But you don't have to start with minus here. You could just put 0. That's why this rectangle a little bit smaller. It doesn't matter. It's just good. We don't want to go beyond this to put minus 0.5. Or you could start from that and then just erase. Here is class boundaries. So why we are using class boundary? In case you want to come up with a histogram with no gap. Class midpoints and frequency, they're points. When you graph it, they all come up with the points, okay? Like here on this one is upper class limit, upper limit of class boundary versus cumulative frequency. So you could come up with a different graph for each. Now, these examples, I think is one of the problems, the homework. We give you all this and we ask you to tell us what percent of all these letters are letter O? What percentages are letter B? See, this is how to do it. So I have the solution for this, and you understand it's very similar to the other ones. And same thing here. So I'll put some example here for you to look, and I have the solution for you. Okay. So go ahead and read all this with the examples. Okay. This one we are asking you to fill a cumulative frequency. Remember frequency, you just add like. You put 1 here, and the second one is 3, and so on. This is a cumulative frequency. So these are the examples, and so I'm going to stop here, and the rest I put it on the next video. So right now, the next subject is stem and leaf. This is what we will discuss on the next video. So you don't have a long video. So this is video number 1.